Solutions. First, we'll start with introduction part. What is a solution? It's a homogeneous mixture. And what does homogeneous means? Which is uniform throughout. For example, if you dissolve sodium chloride in water and you see that, and if you stir it for some time, you see you cannot see sodium chloride and water separately. So it's a homogeneous mixture, or we can use the word solution. Any phase of matter can form solutions. Here we are sodium chloride solid, we are dissolving it in liquid to form a solution. Air is a mixture of different gases. Air has hydrogen gas, nitrogen gas, oxygen gas, and we can, since air is a homogeneous mixture, we can also use the word solution for air. So let's take this. Let's say we dissolve sodium chloride. We dissolve 5 grams of sodium chloride in 100 ml of water to make sodium chloride solution. 100 ml of water. I'm writing it with my finger. That's why it's coming like this. So substance that is present in lesser amount is called solute, and the one which is present in larger amount is called solvent. So in sodium chloride solution, sodium chloride is the solute and water is the solvent. Now solution conducts electricity if it contains dissolved ions. And again I'm going to take the example of sodium chloride. Sodium chloride, when you dissolve it in water, it breaks down to form Na plus and Cl minus. And the presence of these ions can help in conducting electricity. On the other hand, if you take, let's say, hydrogen peroxide, or if you take glucose, and when you dissolve these compounds in water, these compounds do not break down to form the ions. Instead, they stay as neutral, these compounds. Since there are no ions, means it does not, these solutions of these compounds do not conduct electricity, or known as non-electrolytes. So glucose C6H12O6 is a non-electrolyte. H2O2, hydrogen peroxide, is a non-electrolyte. On the other hand, sodium chloride is a electrolyte. In fact, it's a strong electrolyte. Now, we're saying that compound when dissolved in water is form a solution. So how do you find out whether the compound will dissolve in water or not, or will be soluble in water or not? The important thing to remember is like dissolves like. Water is a polar compound, and we have already gone over polar and non-polar in previous videos. Water is polar, so any compound that is polar or ionic compound, that will be soluble in water. On the other hand, non-polar compounds will be insoluble in water. So, for example, sodium chloride is an ionic compound, metal and non-metal. So, will this be soluble in water? Yes. So, it will be soluble in water here. Um, on the other hand, let's take example, sulfur dioxide. Is that soluble in water? Now, sulfur dioxide is it's a polar compound, and if it is polar, it is soluble in water. If you take, on the other hand, let's say you take CCl4, this is non-polar compound, so this one will not be soluble in water. Within the ionic compounds also, you have some rules that there are some ionic compounds which are not soluble in water. And what are those? That list is given to you in your book, that which ionic compounds are not soluble in water. For example, your let's say if you have AgCl, if you have mercury, Ag plus, if you have mercury, or if you have lead 2 plus, with any of the these ions, chloride, bromide, or iodide. These are insoluble compounds. If you have barium ion, mercuric ion, or lead ion, and if any of these ions is with sulfate, then that's also are insoluble in water. So all others will be soluble. So is AgCl soluble in water? Silver chloride? No, it's insoluble. Is lead bromide soluble in water? No. So the one I'm mentioning here are the exceptions. These are the ionic compounds, but they are still insoluble in water. Now this list is given to you in the book, so just so if you want to make sure which ones are not, you can look in there. Now, how does temperature and pressure affect the solubility? So for example, let's say we have water in this beaker and we put salt in there, and this salt gets dissolved and we cannot see it. So and then you put some more salt. It's not that you can keep adding the salt and it's going to keep dissolving. Once the solution is saturated, that means you cannot dissolve any more salt. What happens afterwards? So let's say the solution is saturated and now we see some particles of sodium chloride. But if you start heating this solution, you will see that extra added one gets dissolved. So that means the solubility of solids in liquid increases with the increase of temperature. It's very important to mention the states, phases. We are talking about solid in liquids. On the other hand, let's say you have a soda can, and if you have a soda can and where you have a liquid and the gas is dissolved on the surface of the liquid, what if you heat this soda can? What if you put this in the microwave? Is the solubility of gas will increase in the liquid or decrease? It will decrease. It's gonna pop. So solubility, if we're talking about the solubility of gases in liquids, then that decreases with increase of temperature. Also, we need to understand the effect of the pressure. So there is no effect of the solubility of solids and liquids because you cannot compress them. But here's the thing, if you are talking about solubility of gas in a liquid, if you put more pressure on the gas, means the molecules of the gas will be more in contact with the liquid. So we can say the solubility of gases in liquid increases with increase of pressure.
Made with Doodlecast Pro.